Hi, we're looking at, you're taking a class here called statistics. So in statistics, the thing that we look at is data, right? So everything in statistics always comes back to data. It's really the analysis of that data in order to help formulate answers to different questions. So that's what we look at in statistics, is how do we collect this data and then how do we use this data. In this first part here, we're going to be talking a lot about how to collect the data. There's a whole bunch of different methods, a whole bunch of different ways to do this, and each of them have their own pros and cons. But in order to do that, we're going to be looking at some case studies. So throughout this unit, we'll look at a bunch of different case studies. And the first case study is going to be about stents. So after somebody has a stroke, one of the things that they can do is they can put a stent into the person, and they want to know, does the use of these stents reduce the risk of stroke, or future strokes. So that's what we're going to be looking at here. In order to do this, we probably want to do an experiment. And we're going to talk a lot about what makes an experiment as opposed to an observational study later on. But one of the key things is we need two different groups. We need a treatment group and a control group. The treatment group will get the stents, the control group will not. That way we can actually look at, is there an improvement between the two groups? So after we create those two groups, we would then go out and collect some data, and we'll look at here, some data right here. Each of these are the different patients. We have 451 different patients. They're split up into the treatment and control groups. So we have patient 2 was in the treatment group, and they had a stroke in that 0 to 30 days, also the 0 to 365 days. So we'd collect the data here. This right here is a lot of different, there's a lot of information thrown at you at once, right? Because we have all 451 patients, or we would in the actual data set, and would have the groups they're in and whether or not they had a stroke. Usually we don't want to do that. We don't want to have all of the different groups or all the different cases laid out like this unless we're working with the raw data. Usually we want to have what we call a summary table. So here we'll look at a summary table for this data. So this right here takes the entire data set, the entire big data matrix, which we'll call it, and it splits it up into just the people who in the treatment control group, whether or not they had a stroke or not, in the 0 to 30 and the 0 to 365. So here using this, we can really quickly see about 214 people in the control group did not have a stroke in the 0 to 30 days. So that's 214 out of all the people in the control group. And we do the same thing with the treatment group. We can look at 45 had a stroke, whereas 28 did not have a stroke. So we call these descriptive statistics for this study. And this right here is what we call a summary table. All right, so going off on that, when we collect data, here's another data set right here. So this data set is going to look at what's the grade of the first, it's going to look at loans. So we have loan amounts, interest rates, we have the term of the loan, which is how long it is, the grade of the loan, the state it's in, the total income of the person, and whether or not they rent or mortgage. So we have a bunch of different data here for this study. Each of these rows here, so row 1, 2, 3, all the way down, we'd refer to those as cases or observational units. So each of those is an individual case. So this person right here had a loan amount of $14,500 and interest rate of 6.08 for 36 months. And then it's a grade A loan. So grade A through G represents the quality of the loan and its likelihood of being repaid. The state it's in, the total income of the people is $80,000 a year, and they have a mortgage. So we can see all of this information here. As I said, the rows are the individual cases. The columns here represent the different variables. So we collect data on a bunch of different things. Here we, as I mentioned before, we have the loan amount, the interest rate, the term, and so on. And down here it gives a little description of each of those variables. So when we're collecting data, it's always important to keep it separate, right? Keep your variables separate. Make sure that you're collecting the data you want. So when we're looking at our different variables, there are two key types of variables we have. Right? So there's two key types of data you can collect. You can collect data that's numerical. So this is all data. So numerical, those are going to take on different numbers, right? So 1, 2, 3. Usually money is numerical because it's a dollar amount. The number or the length of the loans there in that previous example would be a numerical because, again, it's the number of months. And then there's also the second type of data we have, categorical. So categorical does not take on numbers, right? So categorical would be looking at how many, or we'd be looking at do they rent or do they have a mortgage, right? So that would be a categorical data set there. So the rent / mortgage. So this would be the length of the loan or the loan amount. The grade of the loan would be a categorical. So there are two different main types of data you collect, numerical and categorical. You definitely want to know whether or not your data is numerical or categorical as you're working with it because you use different techniques depending on if it's numerical or categorical. However, there's actually a couple other things we can look at. So numerical has actually two subgroups to that. And depending on which group your data falls in, we use different techniques again. So we have numerical, which is considered discrete. And we have numerical, which is considered continuous. So discrete numerical numbers have fixed amounts. So again, the length of the loan, the term of the loan, that would be a numerical discrete because it could be 36 months or it can be 48 months, but we're not going to see any 37.36 months. It's going to have whole values. Whereas continuous can take on all sorts of values in between as well. If we're looking at, I guess, one of the examples of the interest rate here, those guys are going to be continuous, right? Because they can be 7.34, 7.345, and so on. So we have our continuous numericals, we have our discrete numericals, and just like with numerical having two groups, categorical also has two separate types of groups. So we have what's called nominal, and we have ordinal. So when we're looking at nominal versus ordinal, really we're looking at the idea that in some cases we have an order that makes sense, right? And that's our ordinal. So sometimes categorical has ordinal numbers. And I'd say the term or the loan grade would be ordinal, right? So because there's a specific order that makes sense, grade A, B, C, D, all the way down to G. A grade A loan is better than a grade B loan. You expect it to get paid back better. Whereas nominal doesn't really have a set order. It doesn't matter which order you display the data. And I think whether or not they rent or have a mortgage, that would be considered nominal, right? You wouldn't consider one of those above the other. So anytime we're looking at data, we always first separate it as either numerical or categorical. And then from there, if it's numerical, is it discrete or continuous? If it's categorical, is it nominal or ordinal? So that's kind of the first thing we look at with data, is what type of data are we collecting? As well as looking at the type of data we're collecting, it also might be important to look at, is there what we call an association with our data, or a relationship between the data? So here we have a scatter plot of home ownership versus the percent of units that are multi-unit structures for U.S. countries. This highlighted dot right there represents Chattahoochee County, Georgia, multi-unit rate of 39.4% and a home ownership rate of 31.3%. So in this data, if we're trying to answer the question, is there a relationship or an association between the data, we look at the general trend of this entire graph, right? So here we have a bunch of dots up here, but then they slowly kind of trail down into the right. So in this case, it does look like the data has some sort of association. It looks like there is what we call a negative association, because as the percent of units in multi-unit structures goes up, the home ownership rate goes down. So as you get more and more multi-unit structures, less and less people own, which should make sense because if you have more multi-unit structures, you would expect more people rent in like apartments and stuff because those come in the multi-unit structures. So therefore, not as many people own because they, in fact, just rent out the apartment. So here, we'd say that they are associated, and then would have to answer the question, is there a dependent variable, right? Is one of those dependent on the other? In this case, it appears the home ownership rate depends on the percent of units in multi-unit structures, right? As this goes up, this one goes down. I wouldn't say the home ownership rate is the independent one here, because as home ownership rate increases, you'd have to tear down, I guess, multi-unit structures in order to make room for that. So probably the way they have it here, the X one is our dependent and the Y. Sorry, the X is the independent and the Y is the dependent here, which is usually how we want to display our data. We also look at another data set here. Here we have the median household income and then the population change over 7 years, right? So is the population going up or down, by how much, and how much is the income? And here you can see not quite as strong of a association. It's kind of clumped together here. It does kind of go up into the right a little bit, but I would say that there's not a whole lot of association here. I'd say the data is probably independent of each other. So when we're looking at data, and we're trying to answer the question, is there an association? We use two different words to describe it. We say either there's a dependent relationship or an independent. Dependent just means as one goes up, the other one goes up or down. And then independent, there's not any real relationship there. Finally, if there is an association, as I kind of mentioned in that other example, you'd want to identify which one is the explanatory variable versus which one is the response. The explanatory usually explains the response, right? So this is because this one happens, this one happens. So you think this one might affect that. If you think about it in terms of x, y, your explanatory is your x, your response is your y. So this is your input, this was your output. As this one changes, this one will change. So definitely that if you have an association or if it's dependent, you want to identify which one is which. Can be difficult because it's not always true that one of them is the explanatory and which one is the response, which we'll look at later. Usually when we're collecting data, there's kind of two ways we do it. Either through an observational study or an experiment. And we're going to talk about those in the next couple of weeks here as we move forward. Key thing, observational study, you're just observing something. You collect the data as it goes. Experiment, you're actually changing how the data is collected. So you're actually controlling the variables. As I said, we're going to be talking about those over the next couple of weeks here now.